Back in 1995, driving a prototype Selectra Sunrise, James Warden squeezed an amazing 375 miles out of one charge on 24 nickel batteries. Today, the last unassembled Sunrise chassis is serving as a model for a future electric kit car being developed by a team from MIT. The team is designing and building a hyper-efficient vehicle.
The main objective was to be able to come up with a mechanism that they could alter these files, that they were handmade parts, so there was no CAD definition of them, but they could bring them into a CAD package software and be able to modify these shapes.
To construct the car with modern automotive manufacturing techniques, the MIT team needed a CAD model of a vehicle which did not exist. GKS's engineers began to 3D scan the entire vehicle's body, chassis, and components. Non-contact 3D scanning is a measurement method that captures everything on the surface of an object, including free-form, irregular shapes, and replicates them digitally on screen. The scanner measures very quickly, picking up tens of thousands of points per second at exceptional accuracies. The various components of the car were scanned 360 degrees so they could be assembled digitally into a three-dimensional model of the entire car. The body was the largest component, and it was scanned from top to bottom, side to side, inside and out. After the scan data was collected, it was converted into a polygon or STL model. From the models, GKS extracted evenly spaced cross-sections and exported them into IGES curves. The MIT engineers used these curves to modify the model. The modified data was then converted into SolidWorks for reverse engineering. Accuracies were improved by the modeling process to create a CAD model that fit together well and was smooth and symmetrical.
What I found interesting on this subject was this was MIT, a very reputable school out east, that was entering competition that was worldwide. And so they were trying to find what is their way that they can get a leg up on their competition to win this prize, the Auto X. And so they were looking on the internet and found us to see if there was a way that we could reverse engineer these car components, which would enable them to come up with a better way to design the car with the expertise that they had here. The missing link was getting it into a CAD design.
The modeling phase took approximately a week and a half because the GKS modelers were not just modeling the scan data in the conditions collected, but rather incorporating corrective measures so that all parts would be symmetrical and fit together correctly. Total project time was 2 weeks, an amazing turnaround time considering the large scale of the project, number of parts, and advanced modeling required. All of the lessons learned in the development process and new technologies advanced by the MIT team will lead directly to other green automotive applications and designs. To learn more about GKS, please visit us on the web at www.gks.com.